Welcome back, chemistry fans. Today we're going to do Unit 4, Topic 4, and this is dealing with something that gets a little bit complex. It's not difficult, but there's a lot of steps to it, and this is called our net ionic equations. So let's jump into it, and let's get started for you. Okay, so in this problem here, what we are trying to accomplish is first off, we got to predict these products. We got to have to convert these words into a form, into a reaction, and then we got to do it into the three different formats that they are asking for: the molecular, complete, and net ionic. So the molecular is just the normal that we've been doing. So I've got sodium and carbonate and hydrochloric acid, and it produces sodium chloride, carbon dioxide, and water. Barely see that because of my bar of options over here. So let me scroll it above. Okay, now you can see it a little bit better. Okay. All right here, so we have a little bit more method to this. Okay. Now, first off, the products all balanced except for the sodium carbonate. It needs a 2 here, and that's because the charge on carbonate is -2. The charge on sodium is +1. So now it's all balanced, but the reaction itself is not balanced. So I've got those 2 sodiums, meaning I need to put a 2 right there. And because of the 2 chlorines, I need to put a 2 right there. Well, now that does take care of the hydrogens because I have 2 over here on the right side. I have 3 oxygens, and there are 2 here and 1 here, so we're okay. So everything has now worked out just by taking care of those sodiums for the most part. Okay, now, complete ionic equation. Now, here is where it gets a little bit messy. Here's where we have to expand this quite a bit. So in the process, we have to write each one of these as a with their states of matter. And we have to break them up into their ionic compound components. So I've got sodium with a +1, and it is aqueous, plus carbonate, and again, carbonate -2, and it is aqueous. Plus 2 hydrogen ions, aqueous, plus 2 chlorine ions, they are aqueous. Now, everything is aqueous there. On the right side, I'm going to have, oh, by the way, 2 of the sodiums. And I know that they were N(2) on the right, on the left side, but that's not how that they present themselves as ions. They separate. They cannot be diatomic. And on the right side, what you'll notice is they're the exact same. And the same thing for my chlorines. Now, we come next, though, to carbon dioxide, which is a gas. It stays together. It does not separate, nor does the water. The water stays the same. They do not separate into ions because they are covalently bonded molecules. Okay, now with that in mind, that is my complete ionic equation. Everything is separated into the ions and its constituent parts. What we have to do on the last piece is now get rid of all of the components that are the same on both sides. So my sodium aqueous goes away because it's the same on both sides. It did not change its state of matter. And the same then for my, for my hydrogens, they did change. Sorry, my chlorines did not change. So they went away because they are the same on both sides. So what's left then is my carbonate aqueous and my 2 hydrogens that are aqueous, producing carbon dioxide, which is a gas, and water, which is a liquid. It's still balanced. I still have 2 hydrogens on both sides. I still have 1 carbon and 3 oxygens. Everything is balanced. We just got rid of the materials that did not change their state of matter. So technically, they didn't even participate in the reaction itself. This is everything that I wish for you to be able to accomplish, not only on the homework, but on the test that's happening Thursday. So thank you very much for your time. Let's talk again soon. Farewell.